All right, so on all the other questions that we've worked through today, they were all polynomials, so there was no domain restriction. This particular problem does have a domain restriction. It has a denominator. So when I draw the derivative number line, it's not really as simple as negative infinity to positive infinity, because when I look at my domain, I would say that my denominator cannot be equal to 0. So specifically, this t plus 4 denominator should not be equal to 0. So t cannot be negative 4. So you'll notice that that negative 4 did come up with the second derivative equal to 0, but it also comes up as a domain restriction. So either way, negative 4 needs to go on the number line. It's a domain restriction. It's also where the second derivative is supposedly equal to 0. Now, that right there should be kind of a pause, that you're plugging in the domain restriction that also happens to be this number of interest. But we'll carry on. So we have our two intervals, and we are testing into our second derivative because we're interested in concavity. Now, remember, for our second derivative, we're going to plug into the second derivative right before we set them equal to 0. So going back to where my second derivative was equal to 0, numerator and denominator, that gives us that I need to plug into negative 34 over t plus 4 to the third. And I'll plug in a number to the left. So maybe I'll plug in like negative 5. So that gives us a negative over. And then here I have the negative 5 plus 4. It is raised to the third, so that's going to be negative 1 to the third. So that gives us a negative. So overall for this fraction, I have a negative divided by a negative, so that gives us a positive. So that tells us our second derivative is positive on the first interval. Now, that positive, because it's the second derivative, is telling us, that positive is telling us that we're concave up on the first interval. And then we plug into the right of negative 4, so maybe I plug in 0. And that gives us a negative over a positive. So that's going to be a negative overall because of that mix of signs. So that gives us a negative. Now, what does that negative tell us? Because we're looking at the second derivative, that negative tells us that we're concave down. So what we would say is we would say we're concave up on the interval negative infinity to negative 4, and concave down on the interval negative 4 to infinity. Now, here's what most students are going to say. Most students are going to say, okay, concave up, concave down, therefore we have an inflection point at negative 4. And so what they'll do is they'll create their little t-chart and say, okay, it's a point. Anytime I have a point, it's an x comma y. So I need to plug in the negative 4 into the original function. And the original function was t minus 13 over t plus 4. And again, this xy I'm just doing because that's usually what our coordinate system looks like, but here the variable is t, so technically it's ty. All right, so I'm going to take my negative 4 and plug it into my original function. And I'm doing this because I'm thinking that I have an inflection point. So if I plug in negative 4 for t, I have negative 4 minus 13 over negative 4 plus 4. That gives me negative 17 over 0. And that is a no. And what is a no? Well, if you put this on your calculator, the negative 17 over 0 is going to give you an undefined number. So this number, negative 17 over 0, is undefined. Now, hopefully you're sitting there saying, well, I've never seen a number comma undefined as a point. So this is the red flag that tells us that there's no inflection point. So if you plug in your x value or your t value and you get an undefined, then even though there is that change in concavity, you are going to have to say that there is none or no inflection point. Now, this will kind of fall out from the problem. Really, the reason why there's no inflection point is if you look at the first derivative is undefined at t is equal to -4. So that first condition that the inflection point needs to have a first derivative that exists is not satisfied here. But what I usually tell students is like, yes, you can look at the first derivative, but it oftentimes comes right out or into practice when you start looking at finding that point and you see that you actually have an undefined y coordinate. So anytime you get an undefined y for your inflection, then you know it's not going to work. There's no inflection point.